Hey, welcome everyone to the ChatLoopBackOff series on the CNCF channel. So welcome everyone. I'm very excited to be here. So if you just connected, tell me where you're coming from. So I'm connected from south of France, where we start to have rain, wind. We feel that clearly the weather has changed towards winter for sure. Just use the chat. So if you probably connected to this live stream, you're probably using LinkedIn or YouTube. So during this hour, we will spend together. So use the chat to exchange. We'll try to look at the chat, bring your questions. Just as a warm up, just let me know on the chat where you are connected from. That would be fun to know which countries are connected to this live stream. So ChatLoopBackOff, for those who never heard about it, well, I will be the host and I will be the presenter. The game is very simple. We take one of the CNCF projects and we try to use it and explain it to you. So I briefly discovered today's technology today, and so I will share at least what I have discovered. I think it's a pretty amazing project. Before we start, I would like to remind that this is a live stream from CNCF. That is, which means there is the code of conduct. So if you interact in the chat, or please be in respect of the code of conduct. We are here to help each other and not to blame anyone. I see that we have Fabrizio. So for Colombia, hi Fabrizio. Thanks for joining in. All right, so I think I don't know. For those who's connected, let me know in the chat if you have heard about KCP, and if you never heard about it, just send a small message on the chat to tell me what you think it's about, and we will discover together what's the actual technology all about. All right, so let me start the actual stream, starting with sharing my screen. I'm going to just slightly change the display. Here it is. Tuck. All right. So first of all, if you go to kcp.io, that's the official website from KCP. When I went to that website today or yesterday, it says open source original scalable control plane for Kubernetes like APIs. So interesting. So what is it all about? That sounds interesting. But anyway, I think the website is amazing, very well structured, a lot of amazing contributors. So they have a Slack channel on the Kubernetes Slack channel. So search for KCP user if if you have questions from a user perspective, and if you're a developer, you have KCP-dev. So this is pretty well. And then of course they have all the documentations that is pretty well structured with all the quick starts using kind, or if you want to use Helm to install an official cluster, you will be able to do this. So I think the docs pretty amazing work from the maintainers and all the people working on the KCP, because I think the docs are very well structured, well organized, and they have a lot of tutorials as well. So you're not going into the blind spot for sure. So for preparing live stream, I have prepared a few things. So let's see what we're going to cover here. So first, let me explain about the architecture. So what I've done here, so I have a home lab here, and I have installed, so I have using the cluster API to spin up several clusters. And here we're looking at the core cluster. So as you know, in a traditional Kubernetes environment, you have your kubeconfig, depending on your user, giving user rights on the cluster. And that laptop, in my case, it's mine, I'm able to connect to that cluster and run command as traditional ones, like get the namespace, anything related to this. Now the question is, what will KCP provide to us? That is what we're going to try to answer, and what I'm going to try to explain. So there's a few things. When you deploy KCP in your cluster, in my case, I use Helm. So it will deploy. I can basically bring my terminal. Let me know if it's not big enough. So I have different kube configs. So let me grab the one that have history and command. Not this one. Up, up. Nope. This one. So so I'm connected to the main. So here is the core cluster that has KCP installed, and then if we get the namespace, we will see that we have a couple of traditional ones. So kube system. I have installed a gateway API, and we have a KCP. So at the end, if you're asking yourself what type of workload we'll have in KCP, I could answer that by looking at that cluster. But what the purpose of this is that once we have installed KCP, then KCP provides a new extraction layer API to basically isolate it, our Kubernetes environments, and that's the pure goal of that. And let me connect now with the. So I've prepared a kubeconfig admin. So now it's the same cluster, but now if I do kubectl get ns namespace, you'll see that I won't see the same namespaces. I see different namespaces, have less view on the cluster. So it's already an isolated view. And then what they have done here, they have introduced this notion of workspaces. Let me grab. So here I have already sets of a couple of workspaces, prod and testing. I can also, they have a kubectl plugin. So we can take WS for workspace and then tree. And we can see how this cluster is organized. So we have a root. So that's the main cluster of KCP. And then underneath we have two workspace, prod and testing. So then if I go to, I can say use a workspace, so then I will basically be isolated to one area. So if I use, let's say prod. So now I'm connecting with the prod. And what will happen is that if I do the same command, up, you can see that I have less namespaces that we had a few minutes ago. We only have the default one. Why? Because I was initially connecting to the other workspace, which is testing. So root basically shows you all the workspaces because it's like a tree view. You have all the privileges of everything. Once you go in one of the workspace, sorry, you will have a limited view on the different resources. So what does that mean? Well, I have prepared something, so I'm going to connect I'm going to connect to the testing workspace. Sorry. Oh yeah. So they have something which is quite clever with this kubectl plugin. It's the concept of folders. So I can say, I'm currently at the root. So I can say cd -- and then it will bring me to the root. So then I can have a cd -- and go back to testing. But here I can say, and now I'm going to use the testing workspace. Here it is. So now I'm in the testing workspace, meaning that same thing. If I do kubectl get namespace, if I don't type with my big hands, that would be easier. We can see we have default and web. So we have a web namespace here, and my intention is to deploy to show you that if I have a folder here in this folder called what is it? Consumer. So I'm going to go to consumer, and I'm going to apply in the consumer namespace. There's a application. So we're going to deploy a demo app in this namespace called web. All right. So that will basically deploy. What is that? Yes, I'm not. Okay, never mind. I was too eager to do that. Let me check on my end. That's the beauty. So, meaning that as of now, I'm connected to the. So if we go back to this schema here that we had, it's now. Oh, sorry. Now, if I go down here, what we have now is I've been connected through this area, so that I'm seeing the entire cluster. And what I did with changing to the kubeconfig of to point to KCP, I'm connected here. So now what I'm doing here is I'm not connected anymore on this namespace. I'm connected here. That gives me access to specific workspace, so I can have a kubeconfig per workspace to limit the view to other people. So that's the idea. And we meaning that KCP has its own sets of API behind the scenes, and then it also can interact with the API server. So we can add a small arrow here just to remind. So basically, it goes back to here up to then do things. And then the other thing that it does, it store a reference of objects. So technically, if I could show you, there is etcd here. There's its own etcd that KCP use. So it will basically, we'll see that once we start doing different use cases, all the objects will be synchronized through etcd, the local etcd that's used by KCD. So then if let's say I have another cluster somewhere that has some resources and I don't need that API, it will sync those resources to KCP, and KCP will be able to expose that to my user. So it's a way of isolating things in a smart way. So that's why in the website, when if you look at it, says, if I go back, it says API Kubernetes like API. So it's not completely a Kubernetes API. It's an abstraction API. And it's allow you to basically have it. And then of course you can connect different cluster behind the scenes. So here I have only one cluster that is behind my KCP, but you can imagine to have a various cluster behind it. So what we're going to do here, I have another cluster where we are going to try to basically put a resource and make sure that resource will be synced to my user that will be connected here. So we'll create a new workspace for that user because it's going to be a consumer. And then at the end, what we want here, this cluster is here. It's completely disconnected. As of now, what I've done in this cluster is have only installed PostgreSQL, like an operator. And here, obviously, this operator doesn't exist here. And the purpose of this is to say, if I'm here and I say I want to have a SQL database, it will basically make the request, and the request with a component will see that's going to sync. The database will be created and will be available in this extracted view from the user. So basically, we are completely isolating the users. We can also, there's different use case that KCP used to cover in the past, where you can deploy things and goes to one cluster or to the other, or could do replicate. So there's plenty of things behind the scenes. So I'll only scratch the surface of KCP. I think there's a lot of potentials behind the scenes in terms of use case that we could definitely do. All right, so let's go back to this terminal. Let me clear it. So it's first, I think I'm not able to deploy it because I should have synced. I mean, it's just I may probably miss something behind the scenes, but let me clear this so that you can see it a bit better. And what I'm going to do here, I will do a couple of. So first, let's show you what I have on the other cluster. So if I go back, if I can, need to just grab the right kubeconfig. Where is it? Up. If I do this, and it's not this one, but it's called up. KCP1. All right, so now I'm using this one. And if I do kubectl get ns, you can see that I have this CNP provider operator, so that expose extra CRDs. So if I grab this namespace to avoid making some handwriting issues, you can see that it's running, it's here. And if I look at the API, you can see that I have some PostgreSQL objects available to create clusters, database, and so on. So this is basically in this cluster. So far, this cluster is completely disconnected to KCP. All right, and that I just wanted to show this. So now let's go back to our home. Come on, up, admin. All right. Before you say if you want to create workspaces, very easy. You say just kubectl. There's command kubectl create workspaces, and then you create a name. So you can basically can be in a specific folder of workspace or folder, we can name it, and then it will create a sub workspace into that. So this is how you can create the hierarchy. And then if you want to visualize the hierarchy, like the actual hierarchy of your workspaces, you use tree. And you can see here I'm connected with the testing last time. So that's why it's still using testing. And in fact, what is interesting, it could be interesting that we look at the actual admin config that I have here up briefly. You'll see that if I look at this one, you can see that in fact, I have, it has created, so this is my KCP class. It's basically the DNS that goes to the front proxy layer of KCP in this main cluster. And you can see that it has already created, every time I create a new workspace, it creates basically a new entry in the kubeconfig. So you can see here, I have the root, a root testing, root, and every time I create a workspace, so we can make the exercise. If I create just a small workspace, you'll see that it will create let's say a test. Okay. All right. I'll create is in use. And now if I do tree, as you can see, test is there. And then if I look at, again, the kubeconfig, kubeconfig here, we should have now the tests somewhere. I did not, because it's part of the testing. It's basically subfolders. But yeah, it's basically supposed to, is creating every time an entry to the kubeconfig. All right, so let's go back to our main scenario. So we are in the admin cluster in KCP now. And what we want to do now, so we're gonna put it as root. So ws use root, or we can say wcd like this. And now we should be, we can say use root, but I think we already use current workspaces root. Okay, so now we have we are using root, and what we want to do here is to create a new workspace for the future cluster. So we're going to create a new workspace called, here it is, provider. All right. And now if I do ws, you can see that we have a provider under root, we have prod, and we have testing. Now that we have this, what we want to do is to prepare a new kubeconfig that will be used for the people using the cloud provider. So I'm going to use a command like this that will basically take this up. I need to change the command. I just saw that there's a mistake in the command. And here, what I'm going to do, I'm going to call this command here. So now I have a new file called provider KCP. Here it is. It's the same one. It's a copy. It's basically just the same thing. And now, but you can see that it's added this provider stuff. And now we're going to do here. All right. We are going to basically create a new kube config dedicated for the provider. So, and so here, let's do it. And what it does here, it says provider -- KCP kube config. I'm getting the credentials, the certificates, and everything. All right. Then I'm doing the same thing for the cluster. All right. And let's use this command. Now I'm using this new config. You can see that we have nothing in this specific config. And then what like I said, if we want to sync things with the cluster that has the actual resources, we are going to do what we call an API sync. So it will export some API objects from our one cluster and then sync it to the other ones. And for this, I have in my what is it? What is provider? Oh, I have missed something. Oh, here. So here I have. Let me show you. I have a file called in the. Let me show it. Provider and called API export. You can see that here I am naming a name called database internal, completely an object. I'm naming an object that will be exported. So that I will have to apply it in this cluster, in this kube, in this subsets of the KCP cluster. So let's do this. Let's apply. No, it's not. All right, so now it's been created. And now what I want to do is to go on the other one, on the actual cluster that has the resources, and install the sync object that will basically connect through this same kube config that we're just using here, and it will sync the objects with a KCP. So for this, again, I need to connect to the cluster that the core cluster that has where is it? Let me grab the command, it will be easier. Up, clear. All right, now I'm going to the KCP kubeconfig 1. So here, if I show you namespace, we'll should see this CNPG operator system namespace. So we are in this cluster now. So if you go back in this diagram, I'm now connected here, and we just created like a workspace here. And what we want to do is going to install a component called the sync. So it's a component in charge of syncing the resources from specific API resources that we've defined, and it will sync it back to the etcd of KCP. And then, which means if I create something here, normally the sync will be applied, and the resource will be created here, and vice versa. So that's what we want to achieve by defining this the specific sync object. All right, now let's go back. By the way, if there's any questions, let me check the chat if there's any questions. Oh, there's a couple of people. So hi from India. Hello. I hope you had a nice Diwali. We have a couple of from Boston's as well. So cool. Hi Tracy, and we have people from Nigeria as well. Cool. Also awesome. So can you zoom a bit your terminal? Is it better now, or do you want me to zoom a bit more? Let me know in the chat if it's required. All right. So I'm not watching the chat intensively because I need to do make stuff here. So I'm connecting on that cluster, and what we want to do is to create this a new namespace in this cluster for our agents. So let me clear so then you can see it on the top. So here I'm just creating a namespace in that cluster which is currently not connected. Here I have the namespace. And we'll see here that what we are going to do. Remember, we have on this. Oh, sorry, I didn't type the right command up. If I do ls here, remember we have this provider KCP kubeconfig that we just created, corresponding to the connections to the provider workspace. Remember that. So what we're going to do here is we are going to simply create a secret in this namespace. And this secret will be a KCP kubeconfig in this KCP sync agent, and we are providing this config file that we have created. So now this cluster here would, through that secret, will be able to interact with the API of KCP. And in fact, moreover than just the API of KCP, but in directly to that specific workspace and not nothing else. Now that we have this, we want obviously to create an RBAC because the RBAC of the future AppSync wants to sync on this specific objects. So depending on I'm going to kind of show you the actual RBAC that I have here. API RBAC. This RBAC is very simple. It's basically, in my case, I'm giving the rights to the objects of PostgreSQL. So depending on what we want to sync, make sure that this RBAC is updated, because obviously you want to give the right privileges to the agent to be able to sync the objects that is currently running on this cluster with the with KCP. So that's is important. That's why let's apply this. So kubectl and RBAC. All right, now we have RBAC created in this KCP sync agents namespace. And the thing that we want to do now is to deploy the actual API sync. So we're going to use Helm. And what we want here is to have a doubt here. Okay, kubeconfig. KCP kubeconfig. How do you name? So let me just double check. This is going to be interesting because, again, I have a discovering as you are. We did. How did we name this? Okay, the secret. Okay, now I got it. So now let me show you the value file, because I was confused about the value file. If I did some, because I tried to customize a bit things. So let me show the values of the value file for the installation. I am basically giving the name of the export of the object. So remember, on the KCP, we create an API export where we said we want to export specific API objects, and we named that database internal. So here I'm making that name database internal, so we'll be mapped to the distant KCP cluster. And then the other thing is here I'm getting the name of the secret. So the secret we created was called KCP kubeconfig. So it will basically grab the kubeconfig using that secret name. And now what we want is to basically install the KCP sync agent. So let me grab the command. So here I'm installing this. Let's cross the fingers that it works. All right, now it's done. Let's check what we have here. So we should have normally namespace is called KCP. All right, so now we have a daemon set, I think, or I think it's a daemon set. It's a deployment with true replica. All right, so we have this installed, and what we want now is to publish a resource. So now that we have created the sync agents, we need to say what we want to sync with. And here I have a resource that I have already created. And if we look at this object, I can show you. I'm asking to sync, so it's the database internal, so the name of the same stuff, and I'm syncing the cluster object from the type of resource that I would like to map. It will get the name and then also the secrets. So I should also have the related objects to the database should be synced, and meaning that the cluster object should be visible in the KCP distant cluster, and I should also see the secret of the corresponding database created by this PostgreSQL database operator. Sorry. So let's apply this resource. Let me check if it's the right namespace. No, it's globalist. Let's go back to, where is it? Where is my, here. Okay, now apply this. So we're applying this in this distant cluster, and now it's done. Now that we have created all the component that allow us to, oh, not this screen, sorry, all the components that allow us to at the end now today we could imagine, so I can just duplicate this. Let me take this, copy up. We created like a small agent, so it's not a real KCP, but we created a small agent here that is basically looking at the CRDs. So we can put like a small arrow like this. That is, it could be it's not a one. The arrow should be in both sides. Yeah, never mind. I don't know how to do this, but and then what it does here is now we can say that this is connected to not the API server directly, but to a sub instance of the API, because it's the workspace in the kubeconfig. Remember that we have created in the secret. It will basically sync those objects here. All right. Let me check if there's any questions in the chat. No, nothing. Awesome. All right. So now that we have done that, we can go back to our core cluster, not the core cluster, the KCP cluster, the admin one. So let me create the admin kubeconfig, and let me just check that I'm there. So we should be in the provider namespace. If I do ws dot, I should see which one I'm connected in that moment, and I'm in the root workspace. All right. So now what we want to do is to create a new one. So let's create a consumer workspace again. All right, let's put it up top so we can see it. And now if I look, we can say get WS3. We should see that we have root, consumer, provider, prod testing, what we've done. So here, what we've done now is we should be, if I do this, I should be already in the consumer. Let me check. In the root, okay. Okay, now we have it. Now what we want to do is similar to the previous exercise. Exercise is not really an exercise, but it's what we've done here is create a new kubeconfig that will be only limited to this consumer workspace. So do the same thing. I am pointing to my admin, the kubeconfig from the KCP admin cluster, and I'm creating a new config consumer KCP. And now what we're going to do is to set the basically how we could connect to this one. So I can do this. Up, we created this. We created now the file. Did I miss a command or something? Oh no, we are here. So let's connect to this this new consumer KCP kube config, and let's check the namespace. And then if I do WS tree, I'm only seeing consumer, because remember, I only have the rights to that workspace. So that's why we create different kube configs, so everyone is isolated. And now what we want, remember, we want to let the consumer wants to connect to the database, and for this we are going to this full file called API binding. And here, what I'm doing here is I'm creating a API binding. So I'm binding on the same way. So I'm going to bind. Let me check out if I didn't do any mistakes on the name of the API. If it with the S, okay. Oof, I was just worried about that, and also on the value files, because if I did something wrong on when I deployed the API sync, it would be a mess. All right, no, it is not. So if I go back to the consumer, I'm gonna bind. So what I'm doing here, I want to bind the database internal. So that's basically the objects, and that is going to be to the root provider. Remember, we have an object that syncs to the KCP provider, and now we are asking KCP to also sync it back to this workspace. So this is going to be giving us the rights to do that. So meaning that we will see the secrets, everything that could be related to this. Okay, now let's apply this object. It's been created. Awesome. And now we have this. Let's say that that's clear. Let's say that we are a consumer. I need to create I need to work on an application, and I need a database. And the use case here is that in this consumer, I have a PostgreSQL YAML file where I'm asking to create a cluster. So it's a PostgreSQL CPNG that is the size of 5 gig, and I want it to be created. And technically, this won't be created in this cluster, because remember, there's no PostgreSQL operator running there. So what it's going to be doing at the back in the background is we create the object. The object will be synced to the cluster provider, and the provider will be synced to the other cluster, and the cluster will create the resource. So now the question is, would that work? That's something that's usually something else. All right, let's try. So it's been created. All right. So now the interesting thing could be to connect to our other cluster. Where is it? Come on. This one. So we're going to the cluster where there's the actual data cluster, PostgreSQL database running, and then get pods. No. All right. Oh, you can see here, it did create something here. There's an namespace, create technical work namespace created by KCP. So if I go that here, you can see that we have an init DB. It's been pending. I hope one thing. I hope one thing is that it's that I have all the. If it's tried to map a PVC, it will be a mess, because I didn't create the storage class here. So let's check what's happening. So normally this cluster should have resources, so it should not be pending. Oh, this great pod. It says unmounted. Typical. All right, so meaning that I need to install something quickly. Let me check if there's a PVC. Oh, that's the demo effect. Perfect. PVC in this namespace. Yeah, there's no storage class defined. So let's create one quickly. So I'm going to deploy, because I'm running on my home lab, I'm going to deploy a small project component called the CSI driver NFS. And then I'm going to deploy a storage class for that specific clusters that I will go to my NAS. All right, so now we have a storage class created called NFS KCP NFS CSI, and then if we have the PVC, maybe I will have the chance to update it. All right, now edit. I will edit the PVC, hoping it works. Stupid. It's called consumer-1. All right, where's the storage class? Up. For those who this is where I'm going to use. I don't remember. PVC. I'm debugging storage class. Storage class. Okay. Come on. Restart policy. No, that's the pod. I'm looking for the PVC object. Where is the here, storage class. Versus one claim, storage class up. Copy up. Let's go back to our, and then here I'm going to add this. I should have done nano. It will be much more. Okay, it works. And then our storage class was named CSI. And then let's update this if it allows me to do that. All right. Whoa, it's been allocated. Perfect. And then let's get the pods to see if it's actually. It's initializing. Oh, I'm excited. I'm excited. All right. We have, I'm looking at the time. Time is running. So let me check if there's any questions so far. You could also make storage class the thanks. Good. Thanks for noting as a default storage class in my actual value files. That's correct. But I was too eager to do it like that way. So thanks, Marvin, for the feedback. So now it's been created. So let me check. And normally this operator, when it creates the actual, so it's been running. Now that we have this, let's go back to our cluster, which is, let me probably have the command somewhere to be faster, to be honest. And I'm going to use this consumer. Oh, gosh. All right, let's go to the consumer. And now if I do kubectl get pods. No, not get pods, but get what's the name, cluster. I should see it. Yep, here it is. We have our pod. We have our cluster that we just created in the other cluster that is synced with KCP, so now I can see it. And technically, also, normally there's we act to sync for secrets. So the actual database secret from here it is. I have my secret for this database now on this other cluster. And so to just recap, where's the to recap here? So we created the database is here, and now we can see that somehow the objects in sync is available here. Not in here. We can imagine that we have a subdirectory, something like. Let's create something here. Oh, shit. Come on. Well, let's create a new one. It will be faster. Up like this. So we created something here. So basically, it's a sub entity of KCP for the consumer. And we see now we have a small entity of this, which is not really a database, but it's at least I have access to the object. So a small stick. So we see here this, and we see the secret. And this just by using KCP, KCP that syncs the various objects across the namespace. So which means if you have different objects and you have different cluster that holds databases or LM workload and you need it, you can use this for this. You don't need to add all those operator everywhere, meaning that you can have operator in dedicated cluster and basically reduce the pressure that you put on your core cluster by adding too much CRDs. All right, I think I'm excited because I thought we will be suffering a bit more, but we did it pretty well. So, well, what time we have left? We have about 10 minutes to go. Just to let you know, so they like I said before, if you are up to playing with KCP, they have done amazing stuff where you have a quick started guide, and you have also a lot of workshops that they have delivered in various conferences. So if you go to the quick start guide, you can see here you can look at the concept and to understand everything that I try to explain as much as I could. But here you have the KCP workshops, and you can see the workshop from KubeCon Paris, KubeCon Salt Lake City, and KubeCon London. So the KubeCon workshop you can follow that. So it lets you go familiar with the notion of workspace that I just did. So check it out. So you just need to install, of course, like I said, the kubectl plugin, which has already did in the previously, and then yeah, it's quite simple. It works pretty well, and so far, the main idea, like I said, well, you can finish with this. The main idea with, like I said, let me go to my core cluster, the admin one, if I have it somewhere, or let me put the export, if I have the export command somewhere. I want to show you what's behind the scenes in the core cluster that hosts KCP. If I do this and go to admin, no, yes, no, the kubeconfig, it's the, which one is it? It's the main kubeconfig. Oh, gosh. Typical, I don't have it. Let's go back in history like this. I have it somewhere. Be patient. But I could do it that way. Otherwise, let me go faster. So I'm going to go up, export, kubeconfig, and it's going to be in this one. Now I'm on the host cluster. Just want to check by looking at the namespace. Yes, we are there. So what I want to show you is to see what you have. kubectl get all dash KCP. All right, what you have here, like I said before, you have the etcd. So there's a etcd running just for KCP. And then you have KCP, it's the internal API server for KCP. And then there's the sort of external, so that's the front proxy. So which means what I'm doing here is I'm exposing the front proxy out of the cluster to be able to connect it through my machine and then let the other cluster reach out to this. So that's the idea. So if you install KCP, you can install it through load balancer, ingress controller, gateway API. So there's API gateway. There's plenty of different way of doing it. So it's quite straightforward. The only thing that you need to achieve that I didn't talk about is that once you have installed it, you want to basically create a kubeconfig with a certificate. So you will have to create a issuer. So you have to check the issuer that is in your cluster for KCP. And the one we want to get is the issuer for the client, the one that will connect to the front end client. So you will have to deploy through the cert manager a new certificate, get it, and you will be able to get the config. So that's short how you can bootstrap that using KCP within your clusters. All right, let me check if there's any other questions. Let me go back to the so could you make? Oh, that's what we see. Yeah. And then there's a big question. Whoa, you introduced KCP very well. I see it presents an ambiguous model of scaling through distributed control plane and logical cluster, targeting massive multi-tenancy beyond Kubernetes workload. From the question is let me write. I don't see it. So, from a platform provider's perspective, how do you think it could realistically mitigate operation complexity, etcd pressure, shard coordination at scale, compared to simpler approach like vCluster that provides an isolated cluster? That's good point. Without a distributed control plane. In your experience, would you bet on KCP's evolutions or rely on virtual abstractions like vClusters? It's an amazing question, Fabrizio. So thanks for asking. I'm not a full expert on KCP, as just like I said before, but from my perspective, I see a lot of need sometimes to isolating things. Virtual cluster is creating a namespace within the main cluster, and then you can basically have some core API objects that are synced to the main virtual cluster. But here the idea is that, as you can see, I was not able to deploy things. It's basically expose those CRDs. So if you want to separate things, make things to build applications, I think it's pretty relevant. And also, I didn't do the sync because I had prepared another cluster. I wanted to regard at the time. I didn't have the time to do that. But I think, from my perspective, it sounds very interesting. My concern usually is when I deploy clusters, I usually have an operator for observability. I use the OpenTelemetry operator. I have Istio that acts extra CRDs. Then you use Caverno, extra CRDs. Then you use any runtime agent, extra CRDs. And then you have so many CRD that you're putting pressure on not pressure, but depending on the size of the cluster, you could basically, like you said, putting pressure on the API server. And I think here it's a way of, if you have toolings that could be ported elsewhere, I think it resolves pretty much. But again, I'm not an expert. Fabrizio, I think if you have more questions, I would definitely recommend to go to their Slack channel. Do we have it? I think it's on the Get Started guide somewhere. When you start it says there's a link. No, I don't remember where it was, but it was somewhere. There's on the Kubernetes Slack channel. Here it is: Kubernetes user group, a user channel. Let me zoom in if you don't see it. Kubernetes users and Kubernetes dev. I just passed some questions today, and I was very surprised of how reactive the project is. They are responding in a very fast way. So if you're interested, I would definitely recommend to reach out to the project. And there is also check the different workshop, because I think from my end, what I learned, bring my attention to this project. I probably want to dig in a bit more. to see the potentials that I can do, especially if, in my case, I have different clusters for my home lab, and I think it could help me on delegating things here and there. There's a up, and good point for someone here. Think 100 V cluster means 100 pods plus all the supporting pods. KCP is just a singleton pod serving 100 virtual control plane, and it cluster is workload oriented, where KCP is KRM mostly. Good point. Thanks for pointing that up. It's a good way of answering it. Yeah, that's a good point. Every time you deploy you're adding more workload to that main pod, namespace pod of vCluster, where here you don't have actual pods running here. It's just an abstraction layer for sure. And I'm looking at the time because time is running. We are at 4 minutes from the end of this live stream. All right, so if you have any more questions or anything to say, please do. You have 4 minutes to do that. Otherwise, it was a real pleasure to work on this, to put some times and look at KCP from my perspective. I think a lot of potentials is there, and I'm very excited about having the chance to cover that KCP. So thanks for letting me this opportunity for as a CNCF ambassador. All right, so if you enjoyed the show, don't forget to like, subscribe. If you didn't have the chance to join us at the beginning of the live stream, not an issue. It's pre-recorded, so you will have the content available on LinkedIn, so you can still rewatch the content. And if you're on YouTube, of course, the video will be there, so you can watch it at your own pace. And then if you have any questions, you can either reach out to me or reach out to, like I said, the Kubernetes Slack channel, KCP users. All right, thanks for spending this time with me. I hope you enjoyed it. At least I enjoyed it to present this session. And see you. You will have other ChatLoopBackOff coming soon. So check the schedule. And there was all other great solutions that we covered. So thanks for spending this hour with me, and see you soon for another